Hello, welcome to the brief video lesson on stars, magnitudes, luminosities, and imaging close double stars. There are times in your research on double stars when it is hard to image two closely spaced stars. And this is because here, as you see in this first picture, they're so closely spaced together that the light, as it hits the CCD chip, as it hits the camera, gets dispersed because of the brightness over multiple pixels. And what happens is the stars will then blend as one, and we can't measure that. So what we want to do is we want to find a way to separate these two stars so that we have stars that look more like the image on the right, more pinpoints, less diffuse, and therefore separated on the image. Now, the first way to try to accomplish this is through varying your exposure time. If your exposure time is low, that will prevent as many photons from reaching the camera, and it may prevent dispersion such as we see here on the left. However, if that's not helping, there are other techniques we can do by using stellar class and filter types to try to limit some of the light that's getting to the CCD camera. This lesson will talk about that process. So we're going to look at a star here. This particular binary star, this is located through the Stelladopy catalog, which you're by now familiar. And in this particular system, we have multiple components. So right now, we're going to focus our attention on the A and the B star, and we want to look to the magnitudes. What we have for the A and the B component right here is we have a high differential in magnitudes. We have a very bright A star at 5.16 magnitude, and we have a very faint star at a 12th magnitude. Remember, in magnitudes, the larger the positive number, like a 12, the more faint that it is. The smaller that number, the brighter it is. In this case, it reports a differential magnitude of almost 7. That's a substantial difference in magnitudes between this star pair. Additionally, we have a separation here of 8.7 arc seconds. So given this differential magnitude and that separation, it may be hard to image these. So using Stelladopy, we found this information. And now on the Stelladopy page, there is a link that says go to Simbad. This lesson assumes that you would have clicked that link. This is what you would see in Simbad. Simbad, remember, is a search engine that combines multiple astronomic catalogs. And what it will do is in the very first star here, it'll give you a found star as close to the center of your search as possible. You were searching, when you clicked on the link, go to Simbad, it's searched by position. And this shows you the closest to that particular position. Now, this gives you a ton of information. There are three areas here that we're going to focus on. One is the magnitude through the B filter. Second is the magnitude through the V filter, which also is a green color. And the last is spectral type. So this tells us the center star has a 6.4 magnitude in blue, and it has a 5 in the green. So what that means is it's fainter in blue, because the larger number, and it's brighter in green, the lower number. So we know that we are getting brighter as we go to the right. Now, we're talking here about spectral type. This is the K3 3-star. I'm going to describe that here with the HR diagram. So in our particular case, we're going to look at the HR diagram here. The first place we're going to go is on the bottom to spectral type, and we're going to look at K. This K3 portion, that describes where in the K it sits. Within the class of K, it starts at 0, which is almost to the G side. That's where 0 sits, is right here. And then it goes to 9, which is right here, almost to the M class. So in this particular case, the K3, it sits right about this particular line. So if I draw up the HR diagram, we have a rough idea what its coloring is going to be. The next is the Roman numeral 3. This gets us here to a giant. We understand this is off the main sequence. That means this star sits right about here on the HR diagram. What that tells us, it's a very large star, it's getting brighter, but it is cool, therefore it is red. Stellar color and temperatures, they have a relation. Let's talk about that relation. Now, back in your class on Wien's law, you're familiar with this graph. And what this tells us is the hotter a particular object is, the shorter the wavelength, the more blue it is. The cooler, the more the wavelength shifts to the right, to the red part of the spectrum. Now, we looked in that K class, we had about a 3000 Kelvin star, and that puts it right about here. So what this tells us, if I look at the red graph alone in this particular case, that I'm going to peak in light right about here. That means I have more of the red light coming through from this star than I would blue light because of this slope right here. More red, less blue. I can use that to my advantage because I know it's giving me a lot of red and not so much of the blue. Now, if I bring all of this together, I know, looking at the HR diagram, I have a K3, which is right here on the HR diagram. It's a redder star. If I use a filter that allows a lot of red light through, such as a red filter or a hydrogen alpha filter, and we have red or the hydrogen alpha, I am going to be giving a lot of light through here. But I also know, through my understanding of Wien's law here on the left, that there is less blue light coming from this because this star, as a K3, is predominantly red. So if I go use a blue filter, the blue is going to allow blue light through, and it's going to block out everything else. So let's see what happened. In the first image here, we used 120 seconds on a red filter, and we have so much light on this CCD chip that you can't see the secondary. In fact, there's so much light, we're starting to get blooming that has occurred here on the star. Well, that's no good. So next, we imaged the same thing. We altered the exposure time, and we used the blue filter. What this did is it shrunk the size of the star. And then we started to see that faint secondary companion right here. So I'll circle it again, this lower right. That secondary companion became visible to us that was not visible up here. Why? Because I manipulated the light output. I said I know it's strong in red, so I got rid of red and I brought blue in, and therefore I was able to image that secondary star. Here's the final comparison. We were unsuccessful on the right with the red hydrogen alpha filter, but successful when we used the blue. This is an example of how we can manipulate filters against star type to reduce the amount of light that we have on an image in order to be able to see our closely spaced double stars. Thank you for your attention. We'll see you on another brief video lesson.